basically assume the following simple case. We have a two classification problem. So you can just look first at this picture here. Okay? So let's say we have two populations, and the populations are defined in that way that they share so-called protected attributes. A protected attribute is something like a male or female or the age and so on. So these are basically attributes which are also schützenswert, it is called, okay? Which can be a problem in a model, which have been a problem in the example I gave you at the beginning. So basically you can make a partition of your attributes for each individual by protected and unprotected variable. Now the shape of these data points gives you two different classes. You can put whatever you want. It should be higher, should not be higher, and so on. Okay? And yeah, so we have a two classification problem. Now, what is basically a fair algorithm? A fair algorithm is an algorithm when it basically calculates the score of an individual, and the score might be in a given range. Then basically the decision function, if this individual belongs to class 1 or class 2, should be basically independent of the protected attributes. Okay? So the model should not do something like, if it's a female, no. If it's a male, yes. Okay? So that's the whole idea. Okay? Now, basically, there are different approaches to tackle that problem. Okay? One is called anti-classification. And what you do here is you just remove all the protected attributes. You remove them. So we are all gray. Okay? So there is no attribute, male, female, and so on. So then you hope basically that the decision function for two different individuals is the same if the unprotected attributes are the same. Okay? In that sense, this algorithm would be fair. Okay? It does not prefer male over female. Okay? So this is one technique which is applied, and probably, or I'm quite sure that it's one option you can have in your IBM tool you release later. Okay? Now the problem is that this has some vectors. It looks good at the moment, but you can cheat it, or basically the data can cheat you somehow. Because let's think about the CV. Sometimes people write like, I was the president of the women's club of something, whatever. Okay, so it might be that even if the system does not know that the CV basically belongs to a woman or a man, it might be that what is written in the CV, that the algorithm somehow makes this relation. Okay? And that's a problem again. So this kind of thing is very simple. You just remove basically some data and you do your classification.
Are you implying that basically if you want to be gender neutral, you physically remove the gender feature?
Yeah, I mean, whatever the protected variable is, I mean, the protected attribute can also be the age or the zip code or whatever. So you
physically remove them from the...
Yes. Okay. Of course, you have a problem when you have 50 protected and 1 unprotected.
Yeah, that's
You should not use that.
Yeah.
Or probably you, I don't know. Okay, the second one is called classification parity. And what you do here is the following. So we have the same basis, let's say. And what you want to achieve here is that if you look at the confusion matrix of both populations, they have to look similar. Or better, they have to look the same. Okay? So it means that you treat both classes equally according to the protected attributes. Okay? So this is another way how you can basically try to be fair in that sense. So it means that basically given a protected attribute from an individual, then if the decision basically rule is that for that protected attribute for that individual is 1, then this should be equally to the probability that the decision is 1 without the protected attribute.
Okay.
It just means that, yes.
So, is this not a way to test whether or not an algorithm is fair,
yes,
as opposed to
exactly,
a way to, because the previous one was a way to kind of make sure that the algorithm wasn't introducing a bias that you don't want. This seems to be like a way to make sure that
yes, yes.
Okay.
I mean, here you try basically to make it fair by removing data.
And there you try to...
And here you try to make it fair to see afterwards, when you have the decision, what happens here. Okay?
Makes sense.
That's a good point. Okay. So this is the second, basically, way to do it. Now, for this classification parity, there are other names like things like equal opportunity and stuff like that. So this all belongs to that class. Okay? So it's useful. Okay? So it makes sense. But why don't people do it more often, or why people don't care about it? It's exactly because sometimes you have this dilemma. To be fair means sometimes your model does not work like you want. Okay? So I mean, it becomes a real problem when you do some illegal stuff, and of course then it becomes a real problem. So you have to remove some bias. Okay, the third one, I will not go into detail, but it has to do with the scoring function and with the protected attribute. It just means that you do that here, plus it should be independent of the scoring function as well. Now the thing is, and I really encourage you to read that paper, which I mentioned now, that all these measures, or all these metrics, what the fairness is or not, so these 3 classes, they were investigated by a few guys, and they did a lot of tests with them, and they could show that none of them basically is robust. So they could crack, or they could cheat all these metrics somehow. And when you read the paper is quite trivial, but they show basically with simple examples that these criteria or these metrics do not really hold for a rigorous statistical testing, okay? Which is a very bad thing, because, at least for IBM, because now you release this nice open source thing, which basically, I had a look a bit on it, okay? But they basically use more or less these kind of metrics. So, now this is quite a new paper, and really, if you're interested in that topic, technically read it. It's a very good paper. I was told to have a talk about 30 minutes. Now we have 46. It's not bad for me. I want to come somehow to a conclusion. So, I mean, of course, you know, we can treat it in a pure mathematical sense, but probably for the audience here would not make sense for all the people here. So I had somehow a mixture of it. But some challenges we have to tackle when we want to basically come up with solutions to these kind of problems is that we need a proper definition of fairness, of bias. There is no proper definition of fairness and bias in the machine learning ecosystem, at least, okay? It's not there. So people are still looking for what is a good definition of it. Who knows Moritz Hart? This guy who follows this guy? So I think now he's in Stanford, or I'm not sure. But anyway, so this guy, for example, he's working very hard on these kind of things. If you're interested, follow him. So then we need kind of end-of-end policies to protect and prevent these kind of discriminations. I mean, the end-to-end, I really mean the whole chain I showed you. When you gather the data, when you select the attributes, I mean, at least there should be some good guidelines, what you should do, what you should do. And we still lack some standardized tests for model quality. Everybody has his own metrics. I mean, there are the plain metrics like the accuracy, recall, precision, F1, and blah, blah, blah. But this is not enough for this business, okay? So people should think hard to come up with better metrics. And for the industry, fairness as a product, I really am very skeptical about that. So I know that Accenture, I think they as well, they launched something. And I must say I'm really, really skeptical about that. And the reason is that if people start to deploy products and they claim that I can solve your fairness problem, then people basically, they get somehow the idea that this problem is solved. But in reality, it's not. Okay? Then I think there sometimes is a know-how problem. So sometimes also I see it in my case. So you do the import NumPy as AI and start doing things, right? So you have your libraries and you do things, and sometimes you are not thinking hard enough what you really are doing. So do I really understand what I'm using here? Can I really write down the equations? Because at the end, this is a mathematical story here, right? If you do machine learning, you can write down the equations. Do I understand these equations? Okay? So everybody working in this area as a data scientist really should study hard to really, really understand these things on the deepest level possible. And then the politics is, I think that they should focus on real problems, okay? Not on the problem of the singularity and stuff like that. And if robots will take all our jobs the day after tomorrow. I mean, these are things worth to think about, to discuss about, but they are at the moment more of philosophical value. Okay? We should think more about how can we make all these algorithms safe for people, and how can we use it for the good, for the society, okay? And tackle those problems. And they should provide much more funding to the research. Okay? I mean, no, it's a disaster, really. What happens in Europe? Nothing. Okay? It's really a disaster. If you come up with an idea, it's very hard to get funding. Yes?
And who should give that funding? The EU or the Swiss government? Or
Yeah, I
the
mean,
United States?
for example, the Swiss National Fund should give more fundings for this kind of research. Or why not build more expert centers? Okay, also paid, yes, paid by taxes. Okay, because the society benefits of this kind of development. So we should basically fund it as well. And this means that we need basically more discussions about these things in the public, okay? Not just among experts. And yeah, then they should think about standards perhaps or recommendations. Now, sometimes you hear all the time, we need regulations. I think it's much too early to speak about regulations, because when you speak about regulation, you have a clear idea in mind what you have to regulate. So what we have to regulate in AI. I mean, this makes no sense, right? We don't know. So, yes?
I mean, for example, the bias would be one thing, right? Like, it doesn't have to be exact rules, but
Yes.
just a guideline.
Yes, but I think it's too early to regulate something. If we don't have proper concepts, proper definitions, proper ideas what we want to achieve with these concepts, we should not regulate something. So we need a bit of time, I think, to get clear what we want to do, how to tackle the problem. And then probably, yes, there should be kind of a standardization. Why not a TÜV for algorithms? Like, let's say you have an algorithm for medical treatment, for example. It should follow standardization X. If it doesn't, the hospital is not allowed to use it, for example. And you as a consumer have the right to see the basically this certificate, and then you can basically get the information, at least in principle, what this algorithm does, how it works. There were some stress tests, when it falls apart and so on. Yes?
For that, we would need laws,
Yes, of course. But the point is here that one should not, do it right now just by let's say, I'm saying that this is not good, this thing, we need a law now. So it needs a bit of time. Probably we need this kind of regulations, yes, why not? I mean, it's not, of course, if I discuss with an AI researcher, it tells me, are you crazy? It's not useful to regulate the research, but nobody talks about regulation of research. Here we talk about regulation of certain application in very sensitive areas. Okay? Yes?
You seem to be very skeptical about the usefulness of metrics and mitigation algorithms so far, but at the same time, when talking about regulations, treating the user algorithms just as a black box to follow, not